This is a video on Chapter 4, Section 5 again. It's going to be finding areas of triangles using Cramer's law and eventually talking about how to use calculators. Here's a triangle with 3 coordinates and vertices. Finding the area of this triangle would be doable, but a bit of a pain. We could find the distance along here using the distance formula. Then we'd want to find this height, and then have to find that height. We have to go perpendicular to this line through this point, write that equation, use that to find this point of intersection, then find that distance there, and then do 1/2 times base times height. It's something that we could do, but it's a pain. Matrices can make this process a lot easier. To find the area of any triangle, if I have the coordinates of the 3 vertices, I take 1/2 and do it times the determinant of this special matrix. Remember, determinant is what these absolute value bars mean. They don't actually mean absolute value. I mean you're finding the determinant. This x1, y1 is like this point here. And this x2, y2 is like this point here. And this x3, y3 is like this point here. And this is just a column of ones. This column of ones will always be ones. They just act as placeholders. They give us a square matrix, a 3x3 matrix, so we can actually find the determinant. I can plug those points in any order I want. I could do this one first, or this one first, or this one first. It doesn't actually matter, as long as I end up with something kind of like this. So I want to find the determinant of this 3x3 matrix. I'm going to copy down 4, -2, 3, 3, 2, -3. At this point, finding determinants should be pretty straightforward. That's 8, that's 9, that's 6. I'm going to do 8 plus 9 plus 6. I'm going to subtract that from another string, which is in green. 6, -12, -6. So this becomes 17 plus 6 is 23 minus -12. So that becomes 35. The determinant of this matrix here, this determinant, is 35. I still have to do 1/2 times that. 1/2 times 35 is 17.5. So the area of that triangle up there is 17.5 square units. You might be wondering about the plus or minus. Why is that plus or minus there? The plus or minus is because depending on how I picked the order of those points to go in, I could have, put these points in any order I wanted to. Depending on how I picked that, this number here could have come out negative. In this case, having negative area doesn't make any sense. So if I had that come out to like a -35, I would have multiplied by -1/2 just to make it positive. That's all that does, makes the area positive. That's how to find the area of a triangle using matrices. Another thing matrices are useful for is called Cramer's rule. Cramer's rule lets us solve systems very quickly. Here's a 2x2 system, ax plus by equals e, cx plus dy equals f, where a, b, c, d, e, and f stand for numbers. If I want to find the x variable, I do 2 determinants, one divided by each other, one determinant divided by another determinant. Same thing over here to find the y variable. And you can see how these columns change on the top a little bit, but the bottom determinant doesn't change, it always stays the same. Memorizing these letters isn't really necessary. In fact, in the next slide I'll show an easier way to understand this. It's actually easier when there's more letters to play with. But I'll give an example of how this works. I'm going to solve this system. Well, these coefficients right here, I call it my coefficient matrix. I want to find either variable, I'll start with x. Those coefficients go in the bottom matrix. 3, 5, 4, -2. In the top matrix, I'm going to have 11, 6, 5, -2. I'm going to find those 2 determinants and divide them by each other. Again, this should be pretty straightforward. I'm just going to multiply and subtract. So it becomes -22 minus 30 on top. On the bottom, I'll have -6 minus 20. That gives me -52 over -26, which is 2. My x value is 2. It's rather straightforward. Obviously, I could just plug 2 in for x and find y really quick. Y is going to come out to 1. But I'll show how to do it with matrices and determinants, because that's the whole point here. To find the y matrix, or the y solution, I would have on the bottom 3, 5, 4, negative 2. And on top now I'm going to have 3, 4, 11, 6. The nice thing about this is I already know the bottom determinant. The bottom one is negative 26. That one never changes. The top one is going to be 18 minus 44. 18 minus 44 is negative 26. So the y value is 1. As we said before, the solution to this is the point 2, 1. Well, for a 2 by 2 system, that's not really necessary. That can be done very quickly. But for a 3 by 3 system, it gets very helpful. And here's where you can kind of start to see the pattern of how this works. In this equation here, or this system, this coefficient matrix is what I call matrix A. So that's the A, B, C, D, E, F, G, H, I. That's what goes down here as matrix A. I'll find that determinant. But the important thing to understand is when I'm trying to find variable x, in this first example I'll find variable x. Finding variable x means I take this x column right here and I replace it with this result column. I call it the JKL, what it's equal to. I call it the result column. That replaces the x column down here. So it goes JKL, BEH, CFI. That's the only change that there is to it. Other than that, it all stays the same. So if I wanted to find the y solution, I would take this same column here, and I would replace the y column with it. This one would stay the same, this one would stay the same, this one changes. So let me show how to do that over here with my numerical example. I'll find y just to kind of show how this works. And my bottom determinant is going to be 2, 1, 3, 2, 3, 2, 3, 2, 2. It's just those coefficients inside that box. My top determinant is going to replace the y column with this column. So I still have 2, 2, 3 for my x's, and 3, 2, 2 for my z's, but the y's become 34, 35, 35. Now I'll find these two determinants. Instead of doing this by hand, because we've done this by hand a lot at this point, or at least enough, I'll start showing you how to do this on your calculator. On my TI-83 Plus, I'm going to press second x to the negative 1. Second x to the negative 1 pulls up that word matrix right there, and here's all my matrices. I have 10 rooms for matrices, matrix A through J. I'm going to scroll over to Edit. I'm going to edit matrix A so it looks like this green one over here on top. So this is a 3 by 3 matrix. I'm going to make this dimension a 3. You can see how that changes the rows. I make this dimension a 3, and that changes the columns. And I'm going to enter things. Here I'll put a 2. Here I'll put a 34. Hit enter between each one. I'll put a 3. Hit enter. 2. Enter. 35. Enter. 2. 3. 35. 2. There's my matrix A. Here, the key is quit. Don't try to clear, don't try to exit, or do second mode to quit. I'm going to go back to my matrix. I'm going to edit matrix B. Matrix B will be this one. It's also going to be a 3 by 3. And I have 2, 1, 3, 2, 3, 2, 3, 2, 2. I'll quit out of there. So now, for example, if I do second x to negative 1 and pull up my matrix and just hit enter on matrix A, it shows me what matrix A was. I can check to make sure it was correct. What I want to do is go second x to negative 1 matrix, scroll over to the middle option, math, I press right, the middle option is math, the first option is determinant, that's what that det means. The determinant of, and I'm going to do second matrix again and just grab matrix A, grab the name matrix A. The determinant of A was negative 37. So that did all the math that I wanted to do otherwise. So I can do determinant of A and divide it by the determinant of B. This is actually going to come out to a decimal, and that's okay. I built it that way. My y value would be 4.11. 4.1 repeating, really. And I can do that again to find the x value, and I can do that again to find the z value. I don't think I will go over it again. I think that should take care of it. Should be able to handle it from there. Hope that was helpful. If you have any questions, let me know.